At this point, you are very familiar with the structure of the atom. You know that atoms have a nucleus full of protons and neutrons. And you even know the properties of the protons and neutrons, that they both have mass, that protons have a positive charge and that neutrons have no charge, and they both have specific functions in the atom. But you don't know a whole lot about the mysterious electron cloud yet that surrounds the entire atom and also has an important purpose regarding how atoms behave. In this lesson, we're going to focus on what the electron cloud is all about and what it does for an atom as we learn about electrons in the cloud around the nucleus. Now, to get us started, let's again take a look at a model atom. And in this case, we're going to look at the atom silicon. Silicon is an extremely important atom because it is one of the two most abundant atoms found in the Earth's crust. Silicon and oxygen are found making up most rocks in the crust of the Earth. Now, as we look at this silicon atom, once again, we're going to have to peel away the outer layer and see what's underneath to really understand what's going on in this atom. We have that nucleus that we've learned a lot about so far, full of protons and neutrons. But what about the electron cloud with all of these electrons outside of the nucleus? This electron cloud is important because it has properties that make atoms behave in a very important way. First, let's begin by looking at the characteristics of the electrons in the electron cloud. Electrons are located outside of the nucleus. They have a negative charge. Each electron has exactly the opposite charge of a proton, a 1- charge. And electrons basically have no mass. Now, technically, electrons do have a very, very tiny mass, about 1/2000th the size of a proton or a neutron. That 1/2000th is such a small size that we usually just round it down to 0. Because 1/2000th is such a small number, it actually rounds to 0 atomic mass units. So it's not exactly correct to say that electrons have no mass. Essentially, when you round it off, they basically don't have any mass. The purpose of electrons is that they cause atoms to bond together. They're the things that connect atoms to one another to make different substances with completely different properties. Chemical bonds are caused by the electrons. And remember, sometimes those chemical bonds can make molecules. Sometimes those chemical bonds can make crystals. And electrons are involved either way. Electrons are the particles in an atom that bond atoms together. All right, those are the characteristics and the functions. There's one other thing that you need to understand about electrons, and it's what happens when an atom gains or loses electrons. Now remember, when atoms gain or lose protons, they change to different atoms, but that rarely ever happens, only in a nuclear reaction. When atoms gain or lose neutrons, they make isotopes of themselves, but again, that rarely ever happens that atoms actually gain or lose neutrons. That's a nuclear reaction. In nature, while radioactivity happens, it's very rare that we observe these radioactive reactions happening where nuclei are breaking down. Instead, most of the time when parts of atoms change, the part that's changing is the electrons. Electrons are lost and gained by atoms all the time. So what you're about to see is different from when we looked at protons and neutrons, because those kind of reactions rarely ever happen in nature, whereas in God's creation, electrons are very commonly swapped between atoms. Now again, let's take a look inside this silicon atom. And right now, if you wanted to count them up, you would see that it has 14 protons, 14 neutrons, and 14 electrons. But like most atoms, silicon is able to change its number of electrons. And silicon is an atom that can either gain or lose electrons depending on conditions around the atom. Let's say, for instance, that silicon gains 4 electrons. Because there are still 14 protons in the nucleus, this is still silicon, but it's no longer just a silicon atom. We just changed silicon to an ion. Changing the number of electrons changes atoms to ions, charged particles that can react with other particles. When we changed silicon by adding 4 negative electrons, we gave it a big negative charge of 4 minus, we made a negative ion. Also notice that because we added electrons to the outside, it actually increased the size of the atom. So compared to a neutral silicon atom, a negative silicon ion is much larger than the silicon atom was before. Now, what happens if we went the other way? Let's get rid of these extra electrons, and we're back to our regular neutral silicon atom. What would happen if instead of gaining extra electrons, we lost electrons? That can happen with some atoms too. In fact, silicon can either gain or lose electrons depending on conditions. As you may have guessed, losing electrons causes an atom to become a smaller positive ion. And let's see what that looks like. I'm going to get rid of 4 electrons in silicon and make a 4 plus silicon ion. Now notice that this is much smaller than the neutral silicon atom was. And it has a huge positive charge, which will cause it to react a different way with other atoms around it. So that's what happens when atoms gain or lose electrons. They form ions. And if they gain electrons, they make negative, bigger ions. If they lose electrons, they lose negative charges. They become positive, smaller ions. Anytime an atom gains or loses electrons, the atom is no longer electrically balanced, and because of that, it's going to react with other substances around it. So now you know why electrons are important. Electrons cause an atom to react and bond with other atoms around them. Electrons are the part of an atom that holds atoms together in chemical arrangements. And if an atom gains or loses electrons, it forms a positive or a negative ion.